All right, so let's see how this screencasting works out. This is John Golden, and I want to use integration by parts to look at the integral of the natural log of x. So the integration by parts rule is about identifying two pieces of an integral, and one of them we're going to think of as a derivative and the other as a function, and then the integration by parts rule switches those two. We multiply the two functions and then integrate the antiderivative of the first function and the derivative of the second function, so switching the roles. So this is a good thing to use with natural log of x because it has a nice derivative, right? Natural log is a mysterious function, but its derivative is 1 over x, which puts us into polynomial-like territory. But that leaves us wanting another function. So if the natural log is going to be the g, what's going to be the f prime? So we can always think about 1 multiplying something, and that's what we do here. And it's a good option because the antiderivative of it is easily understood, right? So if f prime is 1, then f is x, or x plus c. We usually don't worry about the c until the end because we still have more integrals, and we've kind of put together all those constants of integration. So applying the rule, we take the f and the g and multiply them, right? The g is the original, the f is the antiderivative of the f prime. And then we have this new integral to do, where we have f, the antiderivative, times the derivative of the previous one. And in this case, it's particularly nice because those two are inverses of each other. So x times 1 over x is just 1. So we've got the antiderivative of dx, which is x. So we wind up with the antiderivative of natural log of x being x times natural log of x minus x plus c. But can we believe that? Okay, so definitely for something like this, use of a new technique, we should take the derivative, and maybe that'll give us some insight into how could this be the antiderivative. Okay, so if we're claiming that's the integral, then we ought to be able to take the derivative and get back to the natural log. So we have the derivative of 3 things added together, which is going to be adding together the 3 derivatives. Okay, and 2 of those are a piece of cake. The derivative of x is 1, and the derivative of constant is 0. And that first part is really where the meat is. That's the product rule. Okay, so the derivative of 2 things multiplied times each other is the derivative of the first times the second, plus the first times the derivative of the second. And what should be the case when you're doing the derivative to check is that you'll see some of those same things that we saw before, right? Notice there's that x times 1 over x. So the plus 1 and the minus 1 cancel out, and we get just ln of x, right? That's why it was minus x in the antiderivative. Thanks.